We are Uro-stars, and we believe that more attention and resources worldwide should be devoted to the problem of world hunger and sustainable agriculture. We believe that 2 waste products can solve 5 major global problems. 1. Global food shortage, which is set to worsen as population increases. 2. Global phosphate depletion. Currently, crops rely on rock phosphate, which is set to run out in the next 20 years. 3. Magnesium deficiency. As plants are continually harvested and magnesium is not replaced back into the soil, it is a possibility that people will get magnesium deficient, which could lead to health problems. Soil problems, such as erosion and poor water and nutrient retention, could be solved by this. And finally, 5. Phosphate runoff from the currently used manufactured fertilisers cause eutrophication in waterways and lakes.
Anyone can implement our solution anywhere. We created our solution at home using ordinary kitchen equipment.
So what are these 2 waste products? Urine, which is a waste product and is full of nutrients such as nitrogen and phosphorus, but it's mostly discarded. And seeds. We have found that crushing seeds from the cucurbita family releases an enzyme called urease, which breaks down the urine into accessible nitrogen, but we usually throw it away.
In addition, these 2 waste products can be combined with a source of magnesium such as seawater to produce struvite. Struvite is a slow-release fertiliser that only releases its nutrients when it comes into contact with its roots. This means it's only released when the plants need it, and so it's more efficient. It also means that the fertiliser isn't constantly leaching into rivers and waterways, causing the terrible damage done by eutrophication.
We conducted a number of experiments to discover our solution. We found out the average pH of our urine so that we could test for ammonia production by looking for a change in urine pH. Found out which seeds are a good source of urease. Compared the urease activity of cooked, dried and fresh seeds. How to crush seeds in the best way to enhance the urease activity. Monitored how urease acts on seeds over different time periods. Worked out the best urine to seed ratio to break down the urine in a reasonable time period. And worked out how to identify struvite using a microscope. We found that seeds vary in their urease content. These are all part of the cucurbita family. These have fast-acting urease in their seeds, and these have slow or very slow urease in their seeds. Most of the seeds are thrown away as waste by UK supermarkets. We can convert the urea and urine in a matter of minutes, which is usually a process which takes months. We can convert 1 litre of urine with just 10 grams of seeds. Then we can produce struvite using magnesium. We use seawater and we check the presence of struvite using a microscope. We filtered off the mixture of crushed seeds and struvite, dried it and tested the mixture on a fresh batch of urine. The fresh urine quickly reached a pH of 10, indicating that our mixture contains active plant urease.
We conducted a controlled experiment to find out whether our seeds and struvite mixture would be an effective fertiliser. We compared a control with no fertiliser, baby bio, and our crushed seeds and struvite mixture. We conduct these tests twice, once with lettuce and once with spinach. We observed that struvite is an excellent fertiliser, particularly for our leafy green salad plants. We will continue our test on seeds and struvite mixture in outdoor conditions over the next 6 months.
So in conclusion, we have found by combining waste urine and waste seeds, we can create plant-based urease and struvite, which we can use to treat soils. We believe this can help grow more food, prevent phosphate depletion, help combat magnesium deficiency, improve soil structure, and also prevent eutrophication of rivers and waterways. In addition to this, because it's such a simple process and only uses basic technology, it can be used in developing countries by struggling farmers to help grow more food.